Welcome to our last scheduled session.
Yeah, good evening, Sarah.
I hope everyone is doing well tonight and this morning. This session is going to be a little different. We're going to have 3 different topics that we're going to chat about. The first one will be on the analysis and process that we use for setting estimates at NASS. This is a follow-up to Mark's presentation from last week. Then we'll have a presentation on Google Earth by Dave Johnson. And then we'll talk about strategies and moving forward. But first, let me see. Clement, did you want to give a reminder about the evaluations, please?
Thank you, Sarah, and good morning, everyone in Indonesia, and good evening here in the US. Yes, as of this moment, we have only 5 responses in the August survey. And so I sent out email to about 120 respondents or emails. So yeah, we need a little bit more, I guess, a little bit more response rate in the next couple of days. And maybe Garrett would still talk about the next steps, but we do need the results of these evaluation for a report that he'll be doing or sending next week. So I'd appreciate it if those of you who are here listening to me here, if you haven't filled out the August survey, please do so after this training. And then the September one is also coming up an hour after that one. So it's a shorter survey. So if you have those of you who are not in the 5 who responded so far, please fill out 2 surveys, preferably in the next 3 or 4 days. Shorter than that is better. And we definitely would use the responses for our reports and for planning purposes for next year's trainings, both virtual and preferably in person. So please help us strengthen our proposal for funding for next year, so that and this evaluation is really going to help us. And it would be really great if we can say, oh, our participants were responsive in the surveys. Thank you. Thank you, Sarah. Back to you.
Thank you, Clement. All right, without further ado, let's get to the discussion on the board process and analysis that NASS does. Can everyone see the slides? Nod your head, please. Great, awesome. Okay, so first I want to talk about the whole process that we use for estimation, the flow of processes that we use for estimation. First thing to realize is that we have regional field offices and we have headquarters. The regional field offices are responsible for data collection, data cleaning, everything at the micro and macro level as far as review goes. Then after they've cleaned up all the data, we run a summary for the states, and the regional offices may have anywhere from 2 to 7 states within their region. They would set recommendations for those states. The process that they use is often a mini board, a small version of the board process. After they've set their recommendations, they also have to prepare a justification, giving us any comments that are pertinent to why they chose the numbers that they chose. They send that data to Washington. It's encrypted, comes into our headquarters where our commodity specialists can do some pre-board review of the data at the national level. Then the board meets and they set the national estimate. And I would just comment that since our surveys are done consistently across all the states that are in each survey, the national number is going to be the most reliable, the best number, because it's got the largest sample size to it. So we always set a national number and then work down to the states. And this is done again in headquarters, but at this point then they're looking at the state recommendations and reconciling all of the state estimates to add up to the national national estimate. And I'm mentioning non-spec and spec crops. I will cover that more, but it's the speculative crops that Dave had mentioned last night. And tonight we'll be mostly focusing on what's going into the Agricultural Statistics Board and how it works. So as we know, when we have a survey, we can get things like a direct expansion estimator and some ratio estimators. It's just the output from the summary. The ratios are generally either item to item within a survey, or since NASS often uses replicates to make sure, replicate sampling to make sure that we get some of the same farmers in our surveys on an ongoing basis, we can do a current to previous survey ratio. Using those indications from the surveys, we always have questions about them. So how good are these indications going to be? How good is the direct expansion going to be? How good are these ratios going to be? Is there a consistent bias in the indications? What do we need to know about how well these surveys are performing? And to do that, we use difference tables, time series charts, and regression charts. Now, ultimately, the crops and livestock, for that matter, will go through a balance sheet process as well. But I'm not going to really cover that in this session because that would take us another half an hour to an hour to cover balance sheet. But just think about it. If you have maize, at some point after the farmers have harvested everything, some of that's going to be exported. And we don't know that information at the time that we're setting our estimates. That's information collected by Census Bureau, not USDA. So we don't have all the information for a balance sheet, but we can estimate or think about what that balance sheet should look like. But because we do ultimately get more information, we feel pretty good about our previous year's published data because it fits into those year's balance sheets. All right, so I want to start with the difference tables. Basically, we're trying to compare the current survey indications with the final estimates of previous years. These are created and updated by headquarters. Then we'll show some of the time series charts and move forward with that. I think Mark had shown you something like this for a difference table. This is indeed what we use, but it's so busy, so crowded, it's hard to explain. So I made a subset of this table and I changed up some of the column headers so that hopefully it will be easier to understand. So in the far left over here, we just have a year, because obviously we are talking about a single crop year in the United States, so we want to know about corn planted in each of these years. And this, just like Mark's example, this is all made up data. So in the next column over, we have what our board published estimate was for planted acres in all these previous years. Let's pretend that it's 2015 and we're trying to, March 2015, and we're trying to set a planted acres number for corn. We don't really know what that number is yet. That's why I put a question mark in there. What we do know is in this next column right here, this is just a trend line. If you never did a survey, you would have a sense of what the change is from year to year. But it's not very useful, and I certainly wouldn't want to set a New Year's estimate based on that, but we do keep that, and that is interesting information. Instead, what we've got here is the March survey indication. So we conduct a survey in March. I'm only showing the direct expansions, but there would be certainly planted to planted, this year to previous years planted acres ratio estimator. But for now, let's just, for ease of discussion, let's just talk about the direct expansion. So in 2015 of March, we had a direct expansion coming off our survey at 88,278. If this was the only piece of information we had, if this was the first time that we conducted this survey, or if we had a major change so that it was essentially like a brand new survey, this might be what we would want to set our estimate at because we had no additional information. But we do have additional information. We know how well this survey, the March Survey Indications Direct Expansion, has worked historically. So we take a look at the direct expansion compared to the planted acres. And you may notice that for every year, the March survey indication is lower than the final board planted acres for corn. So we can calculate this difference between the direct expansion and the planted acres as a percent of the planted acres from the board divided by the direct expansion. And so once we have all that information, we can calculate average differences. The reason why we use 5 and 10-year average differences is if you just use the previous year, you would get too much input from, say, a weather event. If you average over 5 years, 10 years, you sort of smooth out some of the weather extremities that can affect your surveys. If you go much longer than that, then you're not able to take advantage of the technological changes in agriculture. You know, if you did a 20-year, well, maybe they were using different varieties of corn 20 years ago that they no longer use. So that's why we use 5 and 10 year average differences. And the way I interpret this would be to say that on average over the previous 10 years, the board final estimate has been 4.7% higher than our survey indication for direct expansion has been. And once we have this average, we can then calculate what planted acres would be using just this average, or using this average. Now, all along here, we have not mentioned standard errors or CVs. That is information that we use, most definitely. I always like to keep everything within one standard error, but it's just not in this particular table because that would make the table even bigger and more complicated. So that is a difference table in 5 minutes. We also would have time series charts that we would be looking at. We saw some of these before. This would be corn planted acre, and in this case, you can see this orange line here. This is the March direct expansion that we were just looking at. And this red line here is what the actual board publication is. And you can see that historically, the orange line is always below the board. And that just highlights the same relationship that we were talking about. And Mark showed you similar time series charts for yield last week. He did it back from harvest towards planting. I'm going to reverse it. This is not planting, but mid-season to harvest. And here we have our probability ag yield in green, which is the subjective yield. Then we have our objective yield, which is in blue, and the board published numbers would be in red. And there's a relationship, but it's not as easy to read in the August report for yield for soybeans. But as we get closer and closer to harvest, it becomes much closer. Farmers are always very pessimistic about crops in the United States. So the probability where we're asking them what they think their yield is always, almost always lower than the board published number, the final number. But as we move through the growing season, it gets closer and closer to what the actual number is, because the farmers have a much better idea of what their yield will be. October, it's much closer. November, that looks really nice. And then the final number, excellent for December. But so we have all the indications from our estimators that we have coming off our survey. We would have direct expansions, we would have ratios, we may have multiple surveys. We would have the ag yield survey and then the objective yield survey. We might have a multi-frame survey to where you could get an area frame component, a list frame component, and then a multi-frame component estimator. So there's all sorts of information. It's rarely just one piece of information, but there's even more than that. So we can actually look at the objective yield data in greater detail to get a sense of how this year's crop is doing compared to other years' crops. We can look at the remote sensing information that we may have for the crop. We can look at weather data, and then we have an additional survey called the Crop Progress and Condition Survey, and we can look at that. So this is just an example of objective yield data that we might be looking at for soybeans. It sort of lets you know how the 2016 in September is doing compared to some of the other years. This is actually I think one of the slides that Dave had shown us yesterday to let us know what's going on with soybeans and what the yield is looking like in the different soybean crops, soybean states, excuse me. And this is similarly, this is one of the NDVI tables. I like this because it quickly lets you know where this crop year, the red line is this crop year, and it stops in September, which means that's where we're trying to set an estimate, as compared to the average over, I forget how many years, and then the yellow line, the golden line, is last year. So we can see that in the beginning of the year, this year didn't look very good at all. It was below both the last year's as well as the average, the mean. But then as we got to mid-August, wow, we started to pick up. We got better than average. And right now we're just a tiny bit better than last year. So that tells you something about what the crop year is looking like. I mentioned we have a crop progress and condition crop progress and condition survey. In that, we pick up things like what is the condition of the crop and where is the crop in the growth cycle. So this is just an example of the soybean condition of what percent of the crop is rated good to excellent. And as you can see, I guess this is 2014. That was an excellent year for soybeans because, wow, 70%, above 70% looks good to excellent. Obviously 2012, this line down here, there must have been a major weather event that happened because the condition of the soybeans just tanked. So we have a lot of information to help us set estimates, but what's the actual process that we use? Well, we use the Agricultural Statistics Board was established in 1905. It's gone through a name change. It was created in response to a data leak. Let's consider this a big mistake that we've learned a lot from, and we have not repeated this same mistake in well over 100 years. It really focuses on security and having an accurate, consistent process. So as I mentioned before, the regional field offices interpret their data for their states and they recommend estimates for their states. Then headquarters makes the final determination of estimates. They are the ones setting the national number. They're the ones then setting all the state numbers. There's a geographic review and comparison so that it makes sense, it fits together with all the states, and it also ensures consistency across the states. And again, The larger sample size is going to get you the strongest indication, the best indication. That's why we start with the national level. Now, speculative and non-speculative, we have 5 speculative crops in the United States: corn, soybeans, wheat, cotton, and oranges. These are crops that are all traded on the commodity markets internationally, and that they are very important parts of the commodity market. And so the report that we put out that says how many acres of corn we have, what's our yield going to be, is very market sensitive. So the process that will be describing or am describing is similar across all the commodities, but there's a lot more security added into the speculative commodities, and maize is one of our speculative crops. It requires that both the data and the statistician work in a lockup situation. Now, not every state that grows corn and sets a corn estimate is a speculative state, but it's all the states that account for a very high percent of production are in the speculative state listings. Now, I said the estimation process is similar across commodities, but there is a distinction. We don't do this sort of estimation process for census data and chemical usage data. We just publish the indications there. Our indications, our summary is what we set as our estimates for those two. So what is lockup? It's all about security in many ways. The data is always encrypted when it comes into our headquarters from our states, but this is an extra level of encryption. And once the data is encrypted, it's not decrypted until everyone is in a secured part of the USDA building. So not until everyone is in lockup. And it's literally a lockup. They're in a set of rooms within USDA, and no one gets to leave until the data are published. There's a guard outside. You have to be checked for electronic devices, et cetera, because you can't communicate with anyone outside the lockup area. So once you're in, and you can't talk to the outside world. Additionally, the World Agricultural Outlook Board is also in lockup with NASS. They're on a different floor, and there's a special set of stairs that links the two, but they're in lockup as well. And they're the ones who put out the World Agricultural Supply and Demand Estimates publication. So we have this board process. We're in lockup. Who's there? What are they doing? It's usually about 9 people on the Agricultural Statistics Board, and they have different roles. So there's 2 representatives from our regional field offices, and they're there to brief members on what's going on in the states, what's been the weather, what's going on with the market that they're hearing, what do they know from a regional field office perspective that headquarters needs to know about. Then we also have a survey statistician. This person would be responsible for actually coordinating and leading the survey from headquarters, and they would tell everyone about any data collection issues that occurred, technical issues, etc. We also have a mathematical statistician. This is the person who's running the summaries, running any imputation, etc. And they would share information about the response rates, any missing data, any odd outliers, etc. Then our commodity specialist in headquarters would talk about what's going on with the commodity as a whole. Would also mention what the rounding rules are, any market issues, talk about the state recommendations. And then the remaining people are the heads of the different commodity section, then branch, then division. So sort of the chain of command over the commodity specialist, along with the chairperson. In this screen, everybody has a computer because basically they're sitting in a room with computers all facing one another, and everybody is analyzing their own data. They're hearing the briefing. They're reading what the state recommendations are. If the state's sending comments or something, they're reading those too, and they're arriving at their own national level recommendation. They discuss it amongst themselves. The chair leads that discussion. Everybody's opinion and analysis and justification is considered, and then they arrive at a US estimate. And this is generally done by consensus. It's a number everyone in the room can live with. All right, since they are in lockup, this is an example of the timeline that they had in August. So the report is released at noon, and everything backs up from there. We know well in advance, because we publish in 2019 what the publication calendar will be for 2020. We know it has to be released at exactly noon on a very specific date. So in order to get all this work done, at 12:30 the doors are locked. So everybody has to come into the lockup area around midnight, maybe before midnight. We send the non-speculative data down to the World Agricultural Outlook Board. At 1 a.m., the speculative data gets de-encrypted. From 1:30 to 5:30, that's when the boards actually are commenced. Then after that, the commodity statistician, now that they have a national number, they need to go reconcile and get the state level numbers. So they work on that. By 7:30, the tables must be complete. Then they start, you have to review the report, you have to verify everything. You send it to the printer, because we still have a limited number that go to the printer. And most importantly, we need one printed copy at least for the Secretary of Agriculture. So that would be our Minister of Agriculture. Then about 15 minutes before the report is released, the Secretary of Agriculture or their designated person comes into the lockup area. And once they're in, they don't get to leave until noon either. And they are given a briefing. But more importantly, they are giving one copy of the report that they sign immediately. And then they are told what's inside. So during this entire process, this is the first time at 11:45 that anyone who is a politician and not a career federal statistician sees the data. And at that point, they're not changing it. They're not saying they agree with the numbers when they sign. They're acknowledging that this is a USDA number, that this publication is a USDA publication. Then at noon, the report is released to everyone. If the briefing is over, then the secretary can leave. If it's not, then they finish up the briefing. They also do a briefing on the World Agricultural Outlook Board as well. So I mentioned that there were 5 commodities that are speculative crops. In August, we're only looking at 4: wheat, corn, soybeans, cotton. So for corn, they're from 2:30 to 3:30, and they have 1 hour to review all that data that I talked about, all the different survey indications and the difference tables and the regression tables and etc. All that information, the remote sensing, and discuss, come up with a national number, 1 hour. If you have any questions, please add them to the chat.
Yeah, Sarah, we do have a couple questions since you are on there. You may want to go to your subsetted March corn planted acres slide that showed the difference table for the first one. The question is, could you explain in more detail with an example what you mean by a consistent bias in your context?
Yeah, actually, let me show the chart.
And then the second part, how do we reach this conclusion? What kind of adjustment or treatment needed to deal with this issue?
Okay. If you look at this time series chart, the board is the red. The objective
Can you share
yield.
it?
Oh yeah, I'm sorry. Goodness, I thought I was. Okay, hopefully you see the time series chart. This is just an easy graphical description of what a consistent bias is. The blue line is the objective yield, survey indications. The red line in the middle is the actual published numbers, and then the green line is the subjective yield survey that we do, where we ask the farmers what they think their yield will be. Almost always the green line is below the published number, and the objective yield line in blue is above the published number. So we could say that there is somehow a bias above that has the objective yield always being above the published, and there is a bias that the subjective yield is below the published number. But specifically, if we look at numbers, we can see here that the direct expansion number compared this 78 to this 83, and you just, you know, go down, you can see that the direct expansion is always less than the published numbers. So we know that we have that it's biased below what the actual published number will be. I don't think it's important that there's a specific definition of what consistent bias would be. You know, it could be that 9 times out of 10 you're below. It could be that, you know, 10 out of 10 times or all the time it's below. What we are looking at is how can we take advantage of this historic relationship, and that's where the difference between the board and the direct expansion that we are looking at as a percent comes into play. I hope that answered that question.
Okay, the next question was, given the multiple indications such as the objective yield and the remote sensing result, how big is the discrepancy between the two, and how do you make the final yield figure for publication? Catamonto sent that in right as you were going into the board process, so you may have covered it right after he asked it.
Right, so probably not. I would say that we actually have 3 sets of information. We have the objective yield, the subjective yield, and the remote sensing. At some point in the growing season, they would have all that information. And historically, we didn't have remote sensing. So we are very used to, we know how to handle the objective yield and the subjective yield. And they are looking at those on the charts going, well, okay, it's in between the two because one reads high and one reads low. So then they figure out where the best middle ground is based on all the information that they have. Then once we get the remote sensing data in, well, NASS had to start to figure out, okay, how much do we weigh, you know, how much weight do we give to what remote sensing is telling us? I would say that they consider the remote sensing, and it's an important part, especially probably for acreage. We only have that information for 2 crops for production data. That would be corn and soybeans. And they give it some weight, but they don't give it, like, you know, it's definitely not 100% weight. I don't know what the, you know, what their actual thoughts are. It may depend on the year. It may depend on what's going on with the weather, what's going on with the surveys. But it is a conversation that they would have to figure out where they think the best estimate is. I hope that helped.
I think that got towards it. The next question is, the commodity expert in lockup, is he or she part of NASS or USDA?
The commodity expert, the mathematical statistician, the regional field office, the division director, everybody who's in the Agricultural Statistics Board meeting is an employee of USDA NASS. So they are a NASS person. They are a statistician by training, and NASS, we are very homegrown. We tend to start out as survey or mathematical statisticians, and we end up in management roles. Some of us do. So everybody who's been there in that room has generally been part of the whole estimation process for years.
Okay, and the last one we currently have is, what is the role of the survey statistician on the lockup team?
Okay, so we've conducted maybe 2 surveys, maybe 1 survey. How did the survey go? Was there problems with enumeration? Was there, sometimes one region of your country, they just may have more problems with enumeration. Really bad weather prevented the interviewers from going out and talking to the farmers. That's good information to know. It would explain maybe why there's fewer positive data in that area, because they just weren't able to go talk to people. So they would be able to share that sort of information with the group. All right. Is that it? Yeah.
That's all the questions. Wait. Oh, there's something else coming in. Okay. How to solve the difference between the satellite image period and the direct observation period, because different periods can occur in different phases.
Right. So for our surveys, we always say as of the 1st of the month. Well, not always, but generally we give a very specific date. As of August 1st, what do you think your yield is going to be? Or how many acres did you have in such and such crop? For the satellite image period, maybe Dave or someone could respond to how close they can get to the 1st of the month as far as that goes.
I don't know if I totally understand the question, but from the remote sensing perspective, we are cognizant of the already established calendars that NASS works under. And so we are, so even if the satellite imagery, the data set doesn't fall exactly on August 1st or September 1st, we're cognizant of that and trying to, make the assumption it's close. I've got some background noise, I apologize.
Okay. And one more question right now. I'll have to clarify for this one. What is the source for the board's estimation? Is it from the objective yield result?
I think maybe this is asking, how do we actually come up with a number? So let me, let's pretend that we have not yet done the 2012 August soybean yield estimate. So pretend that red board number, box right here is what we're trying to get at. We have this data from the subjective and the objective. We look and we decide, okay, it's not going to be either point, because we know the objective is always too high and the subjective is always too low. We don't want to go just in between the two. But we would be looking at that weather information, the crop progress, the any regression information, those difference tables that we would be looking at, and we would try and figure out through that group process what the number would be. So we know it should be between 36 and 48, but what that exact number is, that is not coming directly from just one survey point. It's coming from the conversation, the discussion, and all the data points that we have. So it's not just one thing that feeds into it, because we have so much information to consider. And this this time series chart doesn't really show the difference, the impact of the difference table as concretely as the actual difference table would be. Generally speaking, we always want to be within one standard error of the survey. But if there was, for some reason, a really bad survey, actually, I can't think that that's ever happened where you really go outside of one standard error. But Basically, it is not based on just one survey result because we have multiple surveys and multiple indications, multiple estimators.
Okay, continuing along this same line, from your graph, I saw that most of the time your published number is not the same with the results of your objective and subjective yield survey. Is there any specific rule and objective correction to determine the percentage of correction, or just the matter of the professional adjustment?
So if we had a specific rule, we wouldn't really need the board process. We would just create a model and it would spit out an answer. But what we found is we've tried to create that model and we haven't successfully gotten it right. So we have a long history of using the professional adjustment. I kind of like that phrase. And for the time being, that's what we're going to keep. Maybe in some point in the future, we'll have a whiz-bang model to use, but we've yet to find a good one, find one that's sufficient.
That's all we have right now.
Awesome. Awesome. Well, thank you all very much. Our next topic is Google Earth. And for that, I am going to turn it over to Dave Johnson.
All right. I don't have any formal slides, but this is meant to be a little more of a discussion anyway. The reality is I remember I have a day job too and helping establish some estimates. I was a little busier today than I had hoped. But I'm going to talk about, and I want to correct Sarah, we're talking Google Earth Engine, and it's a different product. And no, that's fine. It's a different than Google Earth. And I will share my screen here because I'm going to show some examples. And let me see if I can do this correctly. And did it says, do you see my screen? I'm guessing it says I'm screen sharing, but do you see it?
I'm seeing your Chrome.
With Earth Engine catalog in there?
Yes.
Yes.
Oh, okay. All right. That is my desktop. All right. So before we dive completely into this, I'm heavily a remote sensing person, as you probably learned from yesterday. And the section I sit within at NASS, we are all things remote sensing and GIS, Geographic Information Systems. And traditionally, we would use tools, desktop style tools, and some of these I'm sure some of you have heard of. The common ones would be ArcGIS, which is made by Esri out of California. Really does for mapping. It's great for cartography, drawing polygons or managing polygons. It also does some imagery analysis. We use a tool called ERDAS Imagine, which is more imagery based, but also you can make maps and do image classification. Other tools that people maybe outside of our group would have used are Envy or PCI. So a lot of these are software packages that have been around for 2 or 3, maybe 4 decades at this point, all requiring to be loaded on your desktop computer or maybe on a server. And then to use those tools, you have to put the data in combination. So you're then trying to usually download imagery from some source. It could be NASA, somewhere in Europe, or other sources, and manage all your GIS layers as well. And of course, you need hardware to store all that data, and then often an IT person or two. So you have this big infrastructure to manage all this. Earth Engine takes that paradigm and completely pushes it aside. And so Google, I'm sure everyone's heard of Google. You know, they have their hands in many different things. Google Earth is their browser for, they have kind of this globe interface and you can surf around the world. You're probably familiar with YouTube. Google owns YouTube. Maybe you're familiar with, I don't know if you have Waze. It's a route finding software. Google owns that. My kids use Google Hangouts in classrooms, and we do everything in Google Docs and Google. They've taken over everywhere, and they've also taken over remote sensing and GIS style analysis with Earth Engine. At its core, Earth Engine, it is a set of tools that allow you to analyze data, but to me, it's really about the data sets that they have absorbed into their cloud, and I'm talking computing cloud. And within the web browser now, we'll show examples of what they have. They reach out on anything that's publicly available and free. So this is not commercial data sets, but it has to be generated usually by a government entity. So they've gone out and they download the data to their own servers, and they have weather data, climate data, imagery data, which is what we're really mostly concerned about. And they have different land cover products that may be publicly available, including over the United States, even our cropland data layer. So they have found that important enough, or enough user requests to put that style data in there. So Earth Engine, to me, first and foremost, is this repository of all these terrific, curated, freely available data sets. And they've put them online in one place. If you're a Landsat or a Sentinel data lover, this is the real core of Earth Engine. They have those data sets, the Landsat, they have the whole archive going back to the 70s. Anything that the US Geological Survey and NASA has produced, they have downloaded it and have it ready for use. And now they've been absorbing the Sentinel data. And there's always questions about latency. So how long does it take them to get these data products onto their servers? They have to ultimately download them as well, but their latency is pretty low. So a Sentinel's seen that, you know, maybe it shows up on the Sentinel server in the afternoon. I'm pretty convinced within a few hours Google also has it. So they are constantly reaching out and getting these data sources. If you're in the business like I am, and we all are, and a time-sensitive environment where we're trying to perhaps build a map or do some kind of analysis quickly, we can't be waiting around for weeks for our favorite image to show up. So Google, I think, has done a good job of that. So like I said, to me, the heart of Earth Engine is the data sets that are within it, and they're stored on the computing cloud, wherever those servers are. I actually think they're in the middle of Iowa, somewhere in a big computing warehouse. So that's the most important part. Earth Engine, this tool, it's free. So the access to the data sets within it are free, and the leveraging of the tools within them are free. They do have some licensing descriptions. They're kind of loose, but basically, if you're using it for research, it's totally fair game. If you're using it for a commercial purpose where you're trying to profit off of it, that is not allowed. And then if you're governmental like we are, it's a little bit gray area, but I can tell you, and I know a couple of the people there, one of them particularly well, as long as you're even touching upon research, they're totally fine with you using it, and they're really trying to get after societal good. So let me just go back to the main data set here, not just the data sets. Maybe I'll just go back to it. And so I just went back to the kind of the main data page. And some of these have changed a little bit since I last looked. You know, I'm not a trainer in Earth Engine. I've used it. I would consider myself probably an advanced level person with it at this time. I'm very familiar with the data set, so I have that on my side. I understand what's in there. But for me, the scripting environment, which I'll transition to next, that's been a steep learning curve and probably more difficult for someone given my age. And I'm just used to these desktop softwares where you download data and you do some analysis on your local computer and you spit that result out. So this is very different. And I'm going to transition now. Oh, and you do need to register with Earth Engine, and there is one requirement, and that I know of, that is you need a Gmail account. And those are free, and probably most, if not all of you, have a Gmail account. And then you do have to request access. From what I understand, and they ask what you're going to use it for. So you'd say, I don't know, ag statistics in Indonesia. And from what I understand, they allow everyone access. So they're just trying to get an idea of their user base, but from what I understand, they don't deny people access. Unless they learned you were trying to do something commercial, using it to profit potentially. Or if you were just this massive user and always just using up all the computing resources, they might come and say, have a chat with you, I'm sure via email. But this is what the interface looks like. I'll go full screen on this. And there's 4 components to the interface. The main one is in the bottom. It's the map interface. And like most map things online, you can pan and zoom, and they have a base map in the background. There's no imagery on here right now. In the upper right part of the internet, the interface is basically if you write a command and you spit out a result, it's going to come up here in this upper right panel. It's also, if you have an error message, that's where it's going to spit it out. In the upper left panel is where you store all your programming scripts. This is a programming environment, and which has pros and cons. The con is it's a pretty steep learning curve. The pro is there are tons of examples of things people have already done with it. And so normally it's a matter of going online to they have a user forum and finding an example code or through their documentation and saying, oh, this is basically what I want. I just need to adjust some things from my data set or my area of interest. So if actually I sketched something out today, and I'll show you that. But if I click on this thing, it brings up it's JavaScript code. Earth Engine's native software is JavaScript. You can also use Python on the front end. I'm not a Python person. I actually wasn't a JavaScript person either. So I was like, do I learn German or do I learn Italian? It didn't matter. So I just had to learn something. So I just went directly for the JavaScript. So there may be folks that are listening that are familiar with JavaScript or Python, or may not be. It's an object-based scripting language, and it's pretty elegant, but it's been a challenge for me. But again, through examples and they've lots of documentation, I've been able to hack my way through it. So once you have code in there, I'm going to go ahead and there's a run button up here. I'm going to run that, and I'll tell you what this little demonstration is going to do. So it centered in on Indonesia, or hopefully it did on your screen. And I've put a pull down box in here. This is maybe a little higher level programming, but it gives you an idea of maybe what you can do. Does anyone want to shout out their favorite, do you call it a district or a subnational level? And if no one says anything, I'm just going to pick one at random. Sarah, Mark, do you have a favorite?
I do not. All of Indonesia is wonderful.
I'm sure it is. It's tropical along the equator.
If anybody has a preference, type it in the chat.
Is there an area that's more ag oriented? Would that be in Java or one of these guys? I'm going to pick something, but I can pick something else later. So I picked that. It zoomed to there. I have to move my Zoom window. It's blocking my view. And so what this has done, and this is just purely for demonstration. So it highlighted that district. Hopefully that's correct. The polygons for like country boundaries and sub-national boundaries, there are data sets within Earth Engine in there. So I'm using everything that's on the cloud. So it went to that district, it drew the boundary, and then I had it pull for me the most recent Sentinel-2 imagery that was at least 10% cloud free. And actually turns out on, gosh, I'm trying to remember my notation. I think I do have year, month, day. So we'll call it September 6th. Maybe someone can tell me if it was somewhat sunny that day. And oh, we are near Jakarta. So this was the Sentinel scene, and we can zoom in on that and pan around a little bit. It's just showing the near infrared, the red, and the green channels as a false color infrared. But no, I didn't have to go out and download this data from the European Space Agency. I didn't have to manage it on my own computer. It's doing this on the fly in the cloud. And then I added a couple other things, calculate NDVI from that. So I have a questionable color table I added to this, and those are adjustable. Greens are higher NDVI. We'll call it reddish brown is lower NDVI. I also have, this is something I've been testing out. There are tools in there to try to do some edge detection between different land cover boundaries. So this is just one scene on one date. Something that's very commonly done in Earth Engine, it's probably its strongest point, is the integration of many images over a single area and composite, we call it compositing, to sift out the cloudy areas, sift out the noise, to come up with the very best image through time. And I have an example of that also. We call it a median composite. So and this is taking all the imagery that was collected from January 1st of this year and attempting to go through there and ignore any areas that are clouds. So over a given pixel, there probably was a cloud-free observation. But this image of this area there could be 100 scenes going into that. Sentinel overpasses every 5 days. And so we're, what, 2/3 of the way into the year. So you can get really nice images that are cloud-free and very useful. So I showed the one single scene on September 6th. Versus the composited image. Something, and this is highlighting it a little bit, Earth Engine now allows one to build out an interface so that so a user doesn't have to be, the user of the interface doesn't have to be a coder. So someone could basically develop an app that has the wherewithal and you can put on legends and checkboxes and even charts if you're really savvy, and then hand that over to someone else that maybe is the decision maker and let them use the tool, but they don't have to actually code. It's getting to be a more higher level thing, but the idea is to make it actionable for the non-coding person to be able to use. And I have examples of that even with my own group. I can show you, I wanted to highlight that it works over Indonesia, it works globally, it's free. The performance is pretty good. There are some downsides to it. You are locked into their tools. They have classification tools, they have statistical tools and all that, but maybe they don't have your very favorite classification algorithm, although there's a good chance they do. So you don't have ultimate control over when that data arrives in the system. So maybe there is some latency. I know the MODIS data is slower to get ingested into their system than the Sentinel data. It can be frustrating. I find it fairly addictive. I try to do something and a couple hours go by and I get frustrated and I walk away and somehow I figure it out or I find some piece of code somewhere and I get real excited and it just energizes me again. But it can be frustrating. And it's almost the little things that are more frustrating. This tool, you can take 10,000 Landsat images and crush them down into a single mosaic, and that takes like 4 lines of code. But to create a legend, it might take 40 or 400 lines of code. So sometimes it really does well on the heavy hitting stuff. Simple stuff can be tough. And it's also easy to get overzealous. Indonesia is a pretty big country. And I can imagine if you were to take the Landsat archive and try to integrate all of that, you could quickly be trying to pull together 1,000 or 10,000 scenes, and technically you can do that, but there are computational limits. It can start to slow and get frustrating in that, because naturally you do something at a small scale and you're like, this is wonderful. Then you want to take it bigger or even global, and it can get tough. So I just want to show a couple examples of things I've done in the United States. From a simple example, I told you the CDL data is in there. This allows within Earth Engine to view that data. It's very simple control. This actually works on a smartphone pretty well. It's not necessarily designed for that, but so if I'm in the middle of Iowa or somewhere, I can push this go to current location. I don't know what it's going to do right now, given maybe it won't work on my PC. But so if I was on my phone, it would zoom to my current location. And let's say I was somewhere right here. So it would zoom there, and then it would allow me to turn on off the different years of the CDL. So 2018. So nothing analytical there. It's just a browser, a viewable thing. But it's nice to have that when you're out in the field and like, what was this field last year or the year prior, or even going back to 2010. So that's one example. A little higher level example. And let's see if this will refresh. Again, I have to move the toolbar here. I talked a lot about MODIS imagery yesterday and tracking time series. And I think it's refreshing. I've picked a county, so a small area in the state of Iowa, so in the heart of the United States, in the center. On the top row, I don't know why this one area is not filling in. If I zoom in a little bit. But this is building this on the fly. It's grabbing the MODIS imagery. It's actually the daily imagery from MODIS. And the darker greens are higher NDVI values. And the top row is what is happening this year. And so 2020, I have the period of July 29th through August 11th. I built out a NDVI composite. The darker the green, the higher the NDVI. On August 12th through August 25th is in the middle. We're seeing a little bit of drop in NDVI in this one area. This was the area of a giant windstorm that I briefly mentioned yesterday, so I bet that's partly impacted by that. And then as we move into the season more recently, just the last couple of weeks, the NDVI is dropping in map form, and we would normally expect it to start dropping close to this time of year. The bottom panels are showing what happened the last 5 years on average. So even though we're losing NDVI this year, actually that isn't normal. So usually it takes a little bit longer. So this is an example of an app, a Earth Engine app that's reaching out on the Google servers to get the MODIS data and apply that. This has been a challenge for me, I admit that, to try to build out these kind of widgets and get something useful. And one other thing I'll show you, and this is what my research is kind of focused on it's really been the last few years, but heavily the last few months, is, it actually ties in a lot of what we've talked about. So we have our cropland data layer. It's a supervised classification. So we download to our local servers Landsat data, Sentinel-2 data, and then we have this administrative information that tells us over certain fields what was being grown there, because the farmer reported, oh yeah, I'm over here, I planted maize, over here I planted soybeans, over here wheat. So the holy grail of remote sensing of agriculture is to be able to create a classification without training data. And whoever solves that will be given a good pat on the back, or maybe a drink, or I don't know. So I've been working this problem and using Earth Engine, because with Earth Engine, we have all the historical Landsat data staged and ready for analysis. So the idea is to drill back through time using the CDLs, so we can say, oh, we know what cornfields look like, or where the cornfields were. We also have all that Landsat imagery, so we can see what the spectral signatures, how they tracked through the season and over the different areas of the country too. So a bit of a yada, yada, yada. There's a lot going on, but I have models that are now running to predict the crop cover this year, not using training data, purely using historical information from Landsat and Sentinel and historical CDL information. And as the Landsat and Sentinel imagery appears this year, then applying empirical models. And once again, I gotta move my Zoom toolbar. This area is that same county in Iowa. Yellow is our maize color, green is our soybean color. And this is a model using all the imagery together. I've been doing a few different things. If I just use Sentinel data, I get this type of map. So there are some differences. And there may be some slowness over the internet here, but I'm also looking at, this is just Landsat data only versus Sentinel only data. And the redraws are slow here. I apologize. Oh, there it comes on. So that's the Sentinel opinion of where the crops are. There's some similarity. If you only use Landsat, it's predicting more corn than the Sentinel image looks more reasonable to me. And furthermore, we can also just model the crop based on the rotation pattern. There's a very strong, in this area, corn, soybean, every year it changes. So we can use that information as well. This is an example. It's using random forest decision trees in the background. It's using the Landsat and Sentinel archives, all on Earth Engine, all for free and runnable anywhere in the world as long as you have a web browser and reasonable internet speed. You don't have to have blazing internet speed. You just need to have enough to show the browser. So I talked a lot about that. I'm really excited about Earth Engine. It's another tool in the toolbox, but it is the major tool. And it's been around for a few years now. It's pretty well documented. There's a huge user forum. And so if I ever have a question, I go to the forums, and it's, someone has probably asked that question. And somewhat surprisingly to me that there isn't a competitor yet. A lot of the Landsat, not a lot, all the Landsat data and the Sentinel data is stored on Amazon Web Services and in Google buckets, but no one else has come up with a platform like this. So it's still the state of the art, and it probably will be. So I'll stop there and take some questions. And
okay, you do have some questions, Dave, and just keep sharing for just a minute in case we need.
Killed it. Let me go back. All right.
Well, I'll ask the questions, and you can decide whether
Okay.
you need to go back. So the first question is, yesterday you showed that NASS uses disaggregated MODIS imagery to build models, and that's a high quality compared to some other models. Can you do disaggregated in Google Earth Engine?
The answer is yes. Earth Engine is flexible enough to, I think, program anything. So we could emulate what like that GIMS website does. I would say it's not worth the effort because it's a great website. But say it wasn't doing quite what you wanted it to do, you could build out something with the same idea. It wouldn't look similar, but I do mention the MODIS seems to have a little bit of a latency in Earth Engine. It's not their top priority, so I would have some hesitation about that. But actually in Earth Engine, NASS really likes to work on a weekly time schedule or 14 days. And so the GIMS data through GLAM is every 8 days. So that can get a little bit awkward. So I was trying to mock this up at a 7-day schedule for NASS. It was a bit of a learning exercise for me, but that's an example of like, oh, maybe you don't like that 8-day revisit rate. You can swap it up.
Thank you. The next question, this is referring to when you were looking at Indonesia. Can you share the GE syntax you used? It was a nice GUI to use, Dropbox for layer check. Is that code something you can share?
Absolutely, and I didn't mention that. So the biggest advantage of Earth Engine is all those data sets there. Probably the second biggest advantage is if someone writes code, they can easily share it. And so if I write a piece of code, I can provide a link, and I can do that here, or I could provide the code itself and you can dump it in there. So it makes it really easy to cross-reference other people's codes or help each other. So someone in Indonesia could have something and be like, oh, I'm stuck, or I don't quite understand this. And maybe someone in Russia could be like, oh yeah, I've had that same problem, I can fix it. So it's a much more, I don't know, there's a community of people that like to help each other, and it's, you know, or if we were working one-on-one, we could easily share code. And there's none of this having to deal with software licenses and is the software installed correctly, or what data sets do you have on your computer, because everything's equal access. So I will share that code or example. I'll put it in a wrap-up email for you, Sarah.
Okay, and I will send it out tomorrow. Next question is, how do you classify corn area using this Google Earth Engine apps? And I think this was pertaining to when you were looking at the US.
Yeah, so this is a talk in itself. And so there's a couple things going on that I mentioned. We have all the past cropland data layers going back over a decade now. So we have that information. And then we have the Landsat imagery over the last 10 years. The Sentinel imagery doesn't go back quite that far. It's only the last 4 or 5 years ago. But we can look at the CDLs from those past years and look at the Landsat imagery in the same years and try to understand what the cornfields look like spectrally and how they look temporally through the time. And then we're data mining, so we're letting the computer figuring that out. Like, oh, okay, this is what a cornfield in this certain county looked like, and this is what the red band showed, or the green band, and the near infrared band. So we let the computer build those rules. And then when we get to our current year, we don't have the CDL, but we do have the imagery, at least up to that point in the season. And so we take the rules from the past and apply it to the future. And then there's a final thing is, given the strong rotation pattern we have in the US, I'm also adding that in as a predictor variable. It's almost like trend. So you have some kind of educated guess, not even looking at the imagery, like, oh, it was soybeans last year. That means there's a decent probability it's corn this year. That's how it often works in the United States. Doesn't mean it always is, but that can at least give you a first guess at something, and then you let the imagery try to override that if it disagrees. But when I get that, I'm trying to tidy up all that research, and I'm going to accuracy assess it this fall once we have our CDLs, and try to write something up, and I imagine have some presentations on it as well.
Okay, thank you. We have a comment from Kelly Thorpe, one of our USDA colleagues, that he and Dina Drajat, pardon if I mispronounce that, have worked on some GE scripts to map rice extent across West Java while he was on his Borlaug Fellowship to the US.
Yeah, Kelly, I hope to get to meet you, yeah, I'd certainly be interested in learning more about what you did. And like I said, I am not an Indonesian expert by any means. I know where it is on the globe. I know it's got a lot of islands, but I've never been there. So I don't want to even pretend that I'm an expert on the.
Yeah, I don't know if there's time, but I can show my Google Earth Engine code and just kind of show that if there's time.
Maybe, would it take more than 10 minutes?
No.
Okay, go for it.
I'm curious, so thanks.
Okay. Let me see. How do I share a screen? Let me.
The share screen is probably down towards the bottom. You have to hover over the bottom of the screen in order for it to come up, and then you just select the, you got it.
Okay, so basically when Dena was here in the US, he came, I was his mentor, for those of you in Indonesia. When he came to Arizona, he worked with me for 3 months, and we basically picked out, or we came up with a problem to use Google Earth Engine to look at rice across Indonesia. And to get started with that, there's another ARS scientist at the Tucson lab who had previously done some work on the same topic, only in China. So we visited with him and got a script that is this China rice script. This was like the basis for what we did. I'm not going to take the time to go over the script, but so we looked basically at Sentinel-1 and Sentinel-2 data over West Java. So just to demonstrate really quickly, I can run the script that we developed. If I hit run, hopefully it'll work. Should zoom into West Java there. And then what it's done there, those black points are the points from the BPS objective yield, or whatever you call those
Crop
surveys
cutting.
that you do, crop cutting surveys. I can zoom in and let me see how I zoom in. And you might recognize your sets of 9 points where you have information for a spot or a location. And then it's going to overlay the Sentinel-1 image over top for whatever date that I have selected currently. So let me zoom back out. And so what we're essentially doing now is trying to come up with algorithms to do classification based on the of the Sentinel images based on the classes of rice from the BPS crop cutting. So as I understand, there's I have some notes here about what they, maybe I don't have it here, but anyway, there's 9 classes, and you have different vegetative stages marked with a different integer number. And so what we're doing is essentially coming up with a time series of Sentinel images over the course of a 6-month rice production period. And so that it would basically make a composite Sentinel image. What you're seeing here is actually a composite. So it's taking the different squares that you see as a composite over about a 2-week period, and it's putting them all together to form the image, taking, and then what we do is take the median over the time period, and that becomes our Sentinel image representation over that particular 2-week period. We do that in 2-week chunks over the rice growing season, and then we're trying to come up with classification methods to be able to determine where the rice is located. And I have plans here in the next months to kind of finalize that project and maybe write something up about that as well, which I'll publish. And I'll stop there.
Thank you,
Thanks
Kelly.
for sharing. That's cool. And what something else you highlighted, you can pull in your own polygons or vector data sets, your points, or even your own imagery if you had something unique. So
I might also say too that you can export the images. So if I know Dave mentioned something about liking a classification routine that's maybe in a different software, you can also export images from Google Earth Engine and then do the processing outside. And that's what I am going to do first, because I have some ideas about how I want to do things that I don't really necessarily want to learn the scripting in Google Earth Engine to do it. So I'm basically pulling the images out in 2-week chunks, and I'm going to do processing outside. But Google Earth Engine is definitely a very useful tool for obtaining images in a very easy way. It's one of the main benefits.
And the compositing is just amazing. I mean, it just leaps and bounds beyond anything else. So, again, thanks for sharing. That's cool stuff.
Well, thank you, Kelly and Dave, for that. I think that's a really good representation of what we had hoped these sessions with BPS would be, a way of sharing ideas and sharing tools, or at least, you know, giving you ideas on what you might want to consider for BPS. So thank you for that. Before I get to my ideas for moving forward. I actually want to invite Garrett to come back on and share a few words on ways forward and strategies, etc.
Thank you, Sarah. So I just wanted to, this is the last session of all the trainings that we've done over the past 3 months. And so I wanted to start by thanking all of you from BPS who have joined these sessions, have taken time out of your day to join us and to go through all of these different important aspects of the work in collecting and analyzing agricultural data. You know, I said at the outset that our hope was to be in Indonesia delivering these trainings, and we still retain that hope, although it would most likely be sometime in 2021. I note that today, Indonesia and Jakarta reimposed PSBB, large-scale social distancing, I believe. So we have 2 steps forward and 1 step back. But I want to thank everyone for your patience and your time to join all of this. And hopefully in the coming months, the situation for all of us will improve to allow for international travel sometime next year. I also want to give a very big thank you to Sarah Hoffman, Mark Miller from NASS, as well as all of their colleagues who have participated in these trainings. They all took a lot of time to prepare their presentations and are obviously very dedicated to the work that they do and are very interested in sharing that information. This would not have been possible without all of their great work. I also want to thank my colleague Ugi from the US Embassy, who has joined many of these sessions, all of these sessions, I believe, and who has helped to coordinate all of the invitations and the sharing of the presentations. Her work has been essential to make sure that these training sessions happen on time and as scheduled. Dan saya mau bilang bagaimana Clement bilang survei itu penting sekali. Kita perlu semua orang dari BPS untuk lengkap survei ini. Ini bagaimana kita menerima dana untuk pelatihan seperti ini. Kami harus membayar NASS untuk waktu mereka, dan itu penting sekali untuk Kedutaan Amerika Serikat ada response survei dari BPS dan semua orang. Jadi kalau Anda bisa lengkap survei dari bulan Agustus dan juga survei bulan September, Anda akan menerima survei September, saya pikir besok. Silakan lengkap, dan itu mudah sekali. So just beberapa menit, 5 menit, it makes a very big difference. So terima kasih untuk waktu Anda lengkap survei dari SurveyMonkey. I want to close by just saying that we had a call this week with several people who have worked very closely on this project, and we're all very excited to continue this work in 2021. And so in terms of the next steps, Sarah will talk about some of the ideas of the areas we would like to cover and how we will coordinate with BPS to make sure that we're delivering information that is valuable to you. But I just want to say briefly that a little bit about our process. And that process is we run on fiscal years. Our fiscal year ends at the end of September, and our new fiscal year begins at the beginning of October. Our plan is to prepare a proposal in October to submit to get the funding. And we will draw upon the previous proposal, which also included work in other areas. including livestock and prices that we did not get to during these trainings. But we also want to follow up on areas that we understand require more time and are of interest to BPS. So I recognize, and I already spoke with Pak Kadarmanto recently on a separate training, that we will try to find some way to do more work on the cropland data layer. And certainly I understand from speaking with Sarah that area survey frames are something else that we should spend some more time on. But the process will take us several months to complete the proposal and receive the funding. I am not confident that we will be able to visit Indonesia in January of 2021, but so we are in all likelihood looking at least starting the next year, again, doing some virtual meetings. And I want to say again that the high attendance from BPS at these meetings, the great questions that we receive, is what's motivating us to continue to keep doing this. And it really is a wonderful thing. And it really does go a long way. So I want to thank you all for that. I just want to set the expectation that we will try, probably, if everything is agreeable, and after we confer with BPS and Pak Kadarmanto and Habibullah and whoever else will be helping to direct these projects, we would like to try to start again as soon as possible, as soon as we can receive the funding. And as soon as it is safe, we would like to have our colleagues from NASS, as well as my colleague Justin Jenkins, who spoke about the GATIS project. We'd like to have them all come to Indonesia. So we're going to keep working towards that goal. And I want to just give a very big thank you to all of you for your patience, your continued support. And I look forward to seeing all of you in the near future and to continue working with you on these trainings. So Sarah, I will turn it back over to you.
Thank you, Garrett. I want to echo Garrett's gratitude for your participation. I always have enjoyed working with Indonesians. You guys are so much fun and so informative to work with you guys. I learned a lot about Indonesia when you guys gave the first 4 sessions, talks that you gave. That was very helpful to us to truly get a better sense of what's going on with BPS and in Indonesia. That was fantastic. And then you guys have been very, you've offered very good questions, and you've definitely participated in these sessions. And that's been absolutely fantastic. Like I said earlier, one of my goals was to spark conversations, to bring forth potentially new ideas to BPS, to possibly share new tools or new ways of doing things. And I hope that you have learned something or gotten something that you can use in the future. Or at the very least, simply raise questions about, are we doing it the optimal way? That is the question that we have to ask ourselves as statistical agencies all the time. It's never you get it right once and you can do it that way forever. You always have to be reviewing and reconsidering what you're doing and making improvements. And you guys are clearly making some major improvements as far as your acreage, your area surveys for rice with the area frame. I would ask you to consider merging your area frame survey for rice and for maize together. Excuse me a minute. You would get some very good cost savings and resource savings, I think, if you did that. You would need to rework your stratification definitions, obviously, but I would just offer that as a something for you guys to consider for the future. I would also offer thinking about creating a cropland data layer or something similar for Indonesia for yourselves. Obviously, you guys have different constraints than we have. You have different resources than we have. So whatever you do, will need to fit the Indonesian system and not just be a copy of what the US does. We're very cognizant of that, and I think that is a potential area that we could work together on. Also, we have more information that we could share about GADAS, not me personally, but Justin certainly, that has been, he's discussed just the tip of the iceberg with you guys about GADAS, and I know there's a lot more information, and that would be a great tool for you guys to use in the future. Hang on a second. So I see those as some of the areas that we could work on together in the future, share more information, you know, work together on those things, as well as, like Garrett said, we didn't even get to livestock this year. And then there was more on prices that we could do. So those would be the things that I see as potential areas of collaboration in the future. I'm very curious to know if you guys had any areas besides those or of those that you think would be worth discussing for further collaboration. Obviously, you don't have to come to any hard decisions tonight, but if you had ideas, that would be great to share with us as we go through future discussions. So I will also want to echo Garrett's thank yous for all my USDA colleagues, particularly Ugi, who's really been helpful on this. And again, I want to thank BPS. And those are my final comments. If there is anything anyone else feels the need to share, please do.
Yes, Sarah.
Yes.
Sarah.
Yes.
I would like to convey regard to all of you from Pak Deputy Chief Statistician, Pak Habibullah, and unfortunately he could not join this this last training because he has another business. So I will, on behalf of this, I would once again good evening to everyone in US and a good morning to my colleagues in Indonesia. And I hope each of you and your family is safe and well. I think the time has flown very fast and we are now at the end of our series of virtual training during the last couple of months, or I can say definitely 3 months. I would like to thank you, the USDA team, for this, particularly for your time and courage in preparing and presenting on the slide, answering our question, and sharing with us useful additional material. We have learned many things from all of you so far. All the best practices that you have shared with us are very beneficial for us to improve our agricultural statistics in Indonesia. We will try our best to implement and adopt them in the case of Indonesian. Some topics have drawn our attention actually, as Pak Garrett mentioned already, that such as crop data layer, estimation using remote sensing and GEE. If you don't mind that they could be considered as an advanced training for us provided by the USDA, but Garrett already mentioned that it's not this year probably, I don't know why, and I think the proposal takes some more time, I think. And at the moment, we are developing the use of remote sensing for crop estimation. Our main focus for the time being is how to estimate air in this topic also from the USDA expert. Our goal in the near future is we can produce the same result or map presented by Dave in his slide for major crops such as paddy, maize, and soybean. This is 3 major Indonesian commodity. So many time and many very frequent that all the government institution related to the agriculture produce always ask BPS, when will you provide the maize estimation and as well as soybean estimation? for the best, probably by the end of next year, we can publish the result. As you may already know that we are now in the process of preparing the corn estimation, Indonesian corn estimation using our area sampling frame methodology. But soybean, we have never prepared at all this time, so I don't know when can we publish the result of soybean, accurate soybean estimation. I don't know, maybe 23, 24, or maybe 25, I don't know, because actually 2 years ago we already proposed also for soybean, but our national planning said so. For the soybean, we just delay first. So you should finalize the corn estimation like this. And in that case, crop data layer or CDL, I should say, has drawn our attention, as I mentioned earlier, that I think it will be great if we have a CDL for in the case of Indonesia, and it's very, very useful if we can provide it, and if we can provide it by BPS as you presented in the case of USA. So if you don't mind that, again, I request this topic to be an advanced training for us provided by the USDA team. Actually, we want to know the possibility of developing CDL for Indonesia. The process, step by step, how long it takes, what resources needed, and for your information that until now we only have a paddy field map, or maybe already mentioned by Katie Patron, that Dena already developed the map, rice map for Indonesian, and using our area sampling frame actually. And we don't have a crop map for each crop. Actually, we really need for corn. So that's why during the diff presentation, I asked how do you make, how you classify corn area. This is the second priorities of our commodity, Indonesian commodity. Yeah. And because this is a lot of thing and a lot of big problem for us, and make much debate among the experts, agriculture experts in Indonesia. And I just for your information, then in a year 2023, we will conduct our 7th census of agriculture. I think this time it's a good time that NASS also can give us like a comment for our next agriculture census. Now we are preparing, and starting from next year, we will also in the state of preparation of our 7th census of agriculture. I think it will be interesting if we can produce a CDL as additional outcome of our next round census, if possible. And using remote sensing, one of the important tools for us is a Google Earth Engine, as I asked you, and this is very the topic of diff already presented, and this is much more attracted us that we should, at least we can we will be able to handle in the case of Indonesian. And based on my short discussion with Justin through email, and if I am not mistaken, that there is possibility for us to get training specifically dedicated for this topic. Maybe we can learn from your experience in exploiting GEE for crop estimation and monitoring. A particular topic such as how to deal with cloud is also a matter for us. So focus training on such topic will be very beneficial for us. And once again, thanks so much for all USDA team. I hope this is not the end of our excellent collaboration, but this is the beginning for a stronger and longer cooperation in the future. That's all from me, and stay safe and healthy. Thank you very much.
Thank you. Thank you. Those were some great ideas, and I agree wholeheartedly. I hope this is just the beginning of a wonderful project, because there's so much we can do together. And I think we'll all learn a lot and make your products better, and we'll enjoy it too. So thank you for that. Anyone else with final comments? No? Well, in that case, again, my heartfelt thanks to everyone, USDA and BPS, who's been participating in these sessions. Thank you very, very much. And I hope to be seeing you in maybe a couple of months. Maybe we can, or however long it takes before we can have another online session, and ultimately in person in Jakarta. So have everyone take care, stay safe, and hopefully we'll talk to you in a few months.
Okay.
Good day.
Have a good
Yeah,
day.
thank you so much.
Sarah and all.
Yeah. Pak
Terima
Gareth,
kasih,
thank
Bapak.
you so much for your cooperation.
Ya, terima kasih.
Sama-sama.